This iconic image captures the renowned pale blue dot, a photograph taken by Voyager 1, which depicts our Earth appearing as a minuscule pixel situated a staggering 6 billion kilometers away. This snapshot predates the birth of many individuals, yet it encapsulates all the essential components and materials that constitute our existence within that diminutive blue sphere we call home. However, a particular date holds significance in this context. Merely 34 minutes after capturing this image, the cameras aboard Voyager 1 were permanently deactivated, rendering a spacecraft completely blind. Consequently, it has evolved into the farthest human-made object in space, presently residing at a distance of 24 billion kilometers from Earth. But what prompted the shutdown of the cameras, and what would be necessary to reactivate them? In this video, we will delve into the functioning of the Voyager's cameras and explore the potential sights they might behold if given the opportunity to resume their operations. You are watching Adventures in Space. The Voyager space probes have achieved numerous remarkable feats throughout their space journey. Not only do they hold the record for being the most distant objects in space, but they have also surpassed all others in terms of longevity, having operated for over 45 years. It is truly awe-inspiring to consider that the computers and systems designed on Earth in the 1970s have endured the harsh space environment for such an extended period. Voyager 1, in particular, was equipped with technology that was far ahead of its time, exemplified perfectly by its camera system. On board Voyager 1 are two Vidicon cameras, which can be regarded as early television cameras utilizing analog-to-digital technology. These cameras boasted an effective resolution of 800 by 800 pixels and captured grayscale images with 8 bits of information. One of the cameras featured a wide-angle lens, enabling it to capture detailed views of planets as the probe approached them closely. The other camera, equipped with a narrow-angle lens, had the ability to zoom in and capture finer details of each planet. Additionally, it could turn back and observe our solar system gradually diminishing on the horizon. Prior to reaching these cameras, however, light passed through an optic system that facilitated the creation of colored images. This system employed a filter wheel consisting of violet, blue, green, and orange filters. Voyager would capture multiple images of the subject, each with a different filter. As the light passed through a filter, it would permit only the corresponding color to pass through, while absorbing the other colors. Although the images were captured in grayscale, different areas of brightness were present in each image, indicating varying sensitivity to specific colors. After transmitting to Earth, these images were saturated with their respective filter colors and combined to produce full-color images. Essentially, this process mimics the functioning of the human eye, which relies on 3 color sensing cones, red, green, and blue, to provide us with a wide range of colors. However, within the Vidicon tube of Voyager, the true magic unfolds. After passing through the lens and filter wheel, the light enters the Vidicon tube. The first component the photons encounter is a transparent faceplate made of tin oxide, situated in front of a photoconductive target plate. When the photons strike the target plate, they generate free electrons. The intensity of light on a particular point determines the number of free electrons created. Greater intensity corresponds to a higher quantity of electrons. These free electrons are then attracted to the faceplate, leaving behind gaps on the target plate. Subsequently, a cathode located at the back of the tube emits electrons toward the target plate to scan the image. These electrons reach the target plate and fill in the gaps, generating an electric current. This signal contains the image data and can now be transmitted back to Earth. Voyager's cameras convert light into signals, but what happened next? Each image captures around 5 million bits of data, over half a megabyte. Transmitting this data becomes challenging when the spacecraft is billions of kilometers away. Voyager 1 had a data rate of 115,000 bits per second, taking 43 seconds to transmit an image. The current rate is 160 bits per second, requiring over 8 hours for one image. Moreover, at 23 billion kilometers, the signal takes 21 hours to reach Earth. To conserve power and extend Voyager's lifespan, instruments were shut down, including the camera. The RTG power source decays by 4 watts per year, with Voyager now at 57% of its initial output. The camera alone uses 40 watts. The computers and software used to operate the camera no longer exist. Exposure to space likely affected the camera's functionality. Assuming the cameras were still in good condition, what would they capture if turned back on? Many assumed that Voyager 1, being so distant from the Sun, would be engulfed in complete darkness. However, this is not accurate. Despite being 23 billion kilometers away, the sunlight remains 16 times brighter than the moonlight we experience on Earth, sufficient for reading a book. However, there simply isn't anything noteworthy or substantial enough in Voyager's vicinity to be captured by the camera. If Voyager were to capture an image today, it would be predominantly dark, but the Sun and some planets would appear as faint pixels. Perhaps the most remarkable aspect is that despite traveling 23 billion kilometers, the star constellations in our sky would remain unchanged. To observe a slight shift in the stars and obtain a different perspective of our galaxy, Voyager 1 would need to travel thousands of light years. It will eventually accomplish this feat, millions of years after we are gone and long after we have lost contact with the space probe. You will see us back here every week with more updates on everything space industry related. Subscribe to the channel to stay tuned to the ever-evolving world of aerospace and interstellar exploration. We do 4 essays every week in relevant topics, and if you like this video, you have 2 in front of you right now. As always, this was Georgie with Adventures in Space, and I will see you at the next one.